All right, class, we're going to be talking about nonlinear systems of equations. We've been discussing this now for a couple of days, so let's make sure we got a good handle on it. A nonlinear system of equation is a system in which at least one equation is not linear. So it could be both of them, but at least one of them is not. There can be one solution, multiple solutions, no real solution, or infinitely many to a system of nonlinear equations. So it kind of depends on the different types. So remember, if you remember to class, if we have a parabola, we had 1, 2, or no solutions when it came to a parabola and a line. But when we were comparing the ellipses with the circles in class, you saw that there were multiple different solutions. So it is multiple solutions depending on the shapes that we're looking at. So let's take a look at this first one. So it says solve each system of equations by graphing. So we want to graph these out. So x squared plus 8x plus 13. We can go ahead and create a table here. So if I plug in x is 0, right, I'm going to see that I have y is equal to 13. So it's going to be a really high number. But let's take a look. If I have x is, let's say x is 1. Right. At 1, I end up with x is 1 plus 8 times 1 plus 13. Actually, and I don't want to go 1. Let's do -1 because we want some negative values in there. We want to get closer to the 0, to this origin. So if I plug in -1, I'm going to have 1, and then I have a minus 8, which gives me a positive 7, and then 7 plus 13. It's going to be a -7, sorry. -7 plus 13 gives me a 6. So now we're coming down. So if I plug in -2 here, -2 is positive 4 plus 8 times -2, which is a -16. So -16 plus 13, that gives me a -3. And then we have 4, so that's going to put me at 1. So then let's go ahead and plug in -3. So when I plug in -3, that would give me 9 plus 8 times -3 plus 13. So 8 plus -3, that's going to give me 24, negative plus 13, 9. So my 9 minus 24 plus 13, that's going to give me a negative number of -2. Okay, so if I plug in -4, go ahead and plug in -4 on your end, and when I plug in -4, we're going to see that I end up with -3. So when I plug in -5, right, just plugging in these values here, I'm going to end up with -2. And I should start seeing kind of a correlation here. So that means that at -6, I'll also be at 1 because I've now hit what we call the vertex. And we'll talk more about graphing these later. The vertex is -4 and 3. So let's go ahead and plot this out. So I know that at 0, I'm at 13. I don't think I have 13. 1, 2, 3, 4, 5, 6, 7. No, I only have 10. So that's not going to work. So let's go ahead and plot the rest of this. So then we have -1, we're at 6. So -1, I have 1, 2, 3, 4, 5, 6. At -2, I am at 1. At -3, I'm at -2. And at -4, I'm at 3. Okay. Let me go ahead and plug these back in. -5, -6. Okay. And so this is going to look like this as it curves upward. Okay. So there's our problem. Now let's graph. Go ahead and graph 2x plus 8. Now this is linear. We've been doing this for a while. So here's 1, 2, 3, 4, 5, 6, 7, 8. Now that's 2, so we're going to go down and over. So we're going to go 1, 2 over 1. So notice we already have a match there. Go again, 1, 2 over 1. Okay, so we can see where these two are going to end up. So let's go ahead and draw out our line here. So we see we have a solution here and a solution here. And so our solutions are going to be, in this particular case, it's going to be -1, 6 and -5, -2. Okay. Now, we haven't had the opportunity to look at conics yet and figure out how to graph this. So it's okay for you to use Desmos to graph this. But what this is telling us here is that this is going to be a circle centered at 0, 0. And it's going to have a radius of, because the equation of a circle is x squared plus y squared equals r squared. So the radius is going to be the square root of this, which is 5. So that means I'm going to go out 5 on every side. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's go ahead and draw a circle here. So here's my circle. And now here we have a square root function, but, well, it's a sleeping parabola. So we are going to be centered at -1. Right, so it's going to look something like this. And we'll graph this in GeoGebra because, like I said, we haven't really talked about how to graph this manually. We have a point here. So it's going to look something like this. Okay. And so the points here are going to be 3, 4 and 3, -4. Since it's this point here and this point here where they're matching. Let's take a look at GeoGebra in this case. So for the equation we had x squared plus, oops, what's going on? Plus y squared, and then that equaled 25. So here's our circle. And then we had, the next equation was y squared equaled 8x plus 8. I think it was -8 actually. So we get something like this. So we can see that they're intersecting. They're intersecting at 3, 4, and they're intersecting at 3, -4, which is what we saw. Okay. Since we're on here, let's go ahead and graph the next one. So our next equation is going to be -2 x squared plus 12 x minus 15. Okay, so there's our parabola. It is an upside down inverted parabola. Okay, and then our next equation that we're graphing with it is going to be x minus 4y equals -24. And so notice how neither one of these is touching, right? So this, even if I zoomed out, right, notice how the more I zoom out, we can see that that line goes on forever, but these are never going to touch. So this would be an example of no solution. Okay. All right, let's take a look at the next two. So here we have a square root function. So we have 2 root . Let's see if I can find the root function here. X plus 6. And then outside of that, it's going to be plus 1. All right, since I'm writing on with my stylus, I did add a 2 there just because the square root is known to have an invisible 2 there. So that's similar to just writing the square root here. Let me make sure I got this correct. So I do have y equals 2 square root of x plus 6 plus 1. Yep, that looks good. And then my other function that I'm comparing it with is a linear function of x plus 3y equals 24. So notice here that we have the square root function that does that curve here. And then we have a linear equation. So we're going to see that they actually have an intersect there. It's only one and it's at 3, 7. So let's go ahead and fill this in. So then when we were looking at this one, remember we did have that point there that was going through. This was going to be no solution. So we were centered at 3 and 3. Okay, so parabola was going this way. But then our line had a y-intercept of 6, 2, 3, 4, 5, 6. Right? And as it continued, it looked like this. So we did in fact have no solution. Meanwhile, over here we were at 1, 2, 3, 7, negative 7. And we expanded this way. And recall that our intersection was at 3, 7. So here's 1, 2, 3, 2, 3, 4, 5, 6, 7. I drew it a little too low. Okay. And then the other line was going through 7 as well. So it looked like this. And so remember, this intersection was 3, 7. Okay. So that's how we go about just checking to see those graphs. Let's look at how to do some of these algebraically. And so notice that some of these are going to be a little bit more involved algebraically than what we saw in class necessarily. So let's go ahead and solve this. So in the first one, notice I already have y in that 1 minus y equals 1 minus x phase. So I'm just going to go ahead and plug this in. We're going to do this by substitution. Okay. So can I get finer? So in the substitution, we're going to have 1 minus x is going to equal x squared plus x minus 2. So we're going to go ahead and move this over. So in moving both of these over to this side, remember we crossed the line, we changed the sign, so we're going to get 0. And we're going to have x squared plus 2x minus 3. So we can factor this, and this becomes 0 equals x plus 3, x minus 1. So we're going to break it up because this tells us from here that x equals negative 3 by that 0 product property, and x equals 1. So now I need to break this up and say, well, when x equals negative 3 and when x equals 1, what happens? So what does y equal? Well, y would equal 1 minus negative 3. So therefore, y equals 4. And over here, we're going to have y equals 1 minus 1, so y equals 0. So our two solutions are negative 3, 4, and 1, 0. All right, let's look at number 6 here. Number 6 has y equals x squared plus 3x minus 5, right? So notice we have two squares here. What we can do is, because I have y equals and y equals, we can set them equal to each other. So we're still doing a form of substitution. So we're going to have x squared plus 3x minus 5 equals 2x squared plus 5x minus 4. So let's go ahead and we're going to move this entire expression over and combine and get some like terms. So I'll have 0 equals, so 2x squared minus x squared is going to give me x squared. And then I have that 5x minus a 3x, which gives me a plus 2x. and then I have a negative 4 plus 5, which gives me a plus 1. Let's go ahead and factor this, so I end up with 0 equals x plus 1 and x plus 1. So this tells me that I end up with x equaling negative 1 and x equaling negative 1. So in theory, this is only one solution. We have what we call multiplicity here. This is a multiplicity of 2, right? But we only really care about when x equals negative 1. So when x equals negative 1, what does y equal? Well, then y would equal negative 1 squared plus 3 times negative 1 minus 5. So I just picked one of the equation. I picked that first one to solve. So we plug this in, we're going to get 1 minus 3 minus 5, and therefore y equals negative 7. So our solution is negative 1 comma negative 7. Let's look at the next two. So here, if we wanted to do substitution, I would have to solve for this one. So let's do that. So if I solve for this, I'm going to end up with x equals negative 2/3 y. So we're going to go ahead and plug that in. So I'm going to have, negative 2/3 y plus y squared equals 52. Well, if I square negative 2/3, I'm going to end up with 4/9 y squared plus y squared equals 52. Well, I'm going to add these. So remember, 1y is the same thing as 9 over 9. So this becomes 13 over 9 y squared equals 52. So now to get rid of this, I'm going to multiply by the reciprocal. Multiply this side by the reciprocal of 9 over 13. And so I'm left with y squared equals 36. Well, I'm not done here because I'm not interested in y squared. I want to know what y equals. So this means that y must equal 6 and negative 6. So I end up with two possibilities here. So we need to break this up and figure out what x is. So when y is 6, I have 3x plus 2 times 6 equals 0. Right? So then I end up with 12, right? I move that over, so 3x equals negative 12, so therefore x must equal negative 4. Right? But what about when y is equal to negative 6? Well, then I have 3x plus 2 times negative 6 equals 0. So 3x equals positive 12, so therefore x equals positive 4. So then my solution in this case would be negative 4 comma 6 and 6 comma negative 4. All right, let's continue here. So here we have a parabola and a circle, right? So let's go ahead and do some substitution. So notice that I know what y squared equals, and I have y squared here, so let's plug it in. So I'm going to have x squared plus 2x plus 13 plus 6x minus 1 equals 0. So remember, this is just substituted in for that y squared. So let's combine our like terms here. So I have a 2x and a 6x. I have a 13 and a negative 1. So when we combine our terms, we end up with x squared plus 8x plus 12 equals 0. This is factorable, so when we factor this, we get x plus 6, and we get x plus 2 equals 0. So this tells me that x equals negative 6. This tells me that x equals negative 2. So now we're going to plug them in. So when x equals negative 6, right, we know that y squared equals 2 times negative 6 plus 13. So therefore y squared equals 1. But now I'm going to take the square root of both sides. But remember, every time I take the square root, I take the positive and minus of that square root. So that means that y equals plus or minus 1. So from this side, we actually end up with two solutions. We end up with negative 6 and 1, and negative 6 and negative 1. right? Since y can be both of those values. All right, so now what happens when x equals negative 2? Well, then we have y squared equals negative 2 times negative 2. Oops. 2 times negative 2 plus 13. So y equals 9, and therefore y squared, sorry, equals 9, so therefore y equals 3, plus or minus. For the same reasons that we had two solutions on that end. So then we end up with x is negative 2, comma 3, and negative 2, comma negative 3. So here we do end up with, in fact, 4 solutions. All right, we have 2 more to finish. Let's take a look at number 9 here. So let's go ahead and set them equal to each other since I have a y and a y. So I would end up with x squared minus 6x plus 10 equals negative 3x squared minus 12x minus 5. So let's go ahead and combine these. Let's move this over. Actually, let's move it the other way around so I can get that positive numerator. So we move it over and we combine our like terms, right? Negative 3x and x squared, negative 12x and 6. So we're going to combine these terms. We end up with 4x squared plus 6x plus 15 equals 0. Now this is not factorable, so when we get something that's not factorable, we're going to go ahead and plug it into the quadratic formula. Remember that the quadratic formula is negative b plus or minus the square root b squared minus 4 times ac all over 2a. So let's identify. So notice that my a is equal to 4, my b is equal to 6, and my c is equal to 15. So if we plug this into the quadratic formula, we end up with negative 6 plus or minus, negative 6 plus or minus 6 squared minus 4 times 4 times 15 all over 2 times 4. So therefore x equals negative 6 plus or minus the square root of negative 204 all over 8. Now because I have a negative, that means that this is going to turn into a complex number or an imaginary number. And so we have negative 6 plus or minus 2i, we can rationalize this a little bit, over 51 all over 8. And so off the top, just because I already know I have a negative, I have a complex number, I have an imaginary number, this is going to be no solution. So we know this because we have imaginary numbers. Okay. So that's a no solutions example there. All right. We're at 23 minutes. Go ahead. I want you to try this one out. Pause the video right now. Try this one out. See if you get it. All right. So hopefully you took that moment to pause the video and check your answer now. Is this what you got? If this is what you got, congratulations. If not, go ahead and check out the work that I have here compared to what you came up with, and hopefully you can find your mistake. But always reach out if you have any questions.